Welcome to Clean Energy Explained, where we simplify the future of power. If you love learning about solar, wind and clean energy, hit that subscribe button. Now let's talk about wind turbine power. The wind is a powerful force. It can shape landscapes and drive mighty storms. Its invisible hands can carve out valleys and topple trees, demonstrating its raw, untamed strength. But did you know that we can also harness the wind's energy to generate electricity? This transformation of natural power into usable energy is a marvel of modern engineering. This is where wind turbines come in. These towering structures capture the kinetic energy of the wind and convert it into electrical power. These elegant giants with their graceful blades reaching for the sky are becoming an increasingly common sight across the globe. They stand as symbols of our quest for sustainable energy, but just how much power can a single wind turbine really generate? The answer lies in the intricate design and placement of these machines. The answer, as with many things in nature, is not so simple. It varies based on numerous factors including the turbine's size, the wind's consistency, and even the altitude. It depends on a variety of factors from the size of the turbine to the strength of the wind. The location and environmental conditions play crucial roles as well. In this exploration we will delve into the world of wind energy, uncovering the science behind these magnificent machines. We'll look at how they are built, maintained and optimized for maximum efficiency, and discovering the true potential of this renewable resource. Wind energy holds the promise of a cleaner, greener future. Join me as we unlock the secrets of the wind, understanding its power and potential, and explore its potential to power our future. Together we can embrace this natural force to create a sustainable world. Before we can understand the power of a wind turbine, we must first understand how it works. Wind turbines are fascinating machines that harness the natural power of the wind to generate electricity. Imagine a giant windmill, its blades turning slowly in the breeze. These blades are designed to capture the kinetic energy of the wind. This is the basic principle behind a wind turbine. The wind's energy is converted into mechanical energy through the rotation of the blades. As the wind blows, it pushes against the blades of the turbine, causing them to rotate. The design of the blades is crucial for maximizing efficiency. This rotation turns a shaft connected to a generator located inside the nacelle, the box-like structure at the top of the turbine tower. The nacelle houses all the critical components. The generator is the heart of the operation, converting the mechanical energy of the spinning shaft into electrical energy. This process is what ultimately produces the electricity we use. This electricity is then transmitted through cables down the tower and into the power grid, where it can be used to power our homes and businesses. The entire system works seamlessly to provide a renewable source of energy. For individual homeowners or small farms, small wind turbines offer a way to harness the wind's energy on a smaller scale. These turbines, typically with a rotor diameter of up to 30 feet, can generate enough electricity to power a home or supplement its energy needs. The amount of power generated varies depending on the turbine's size and the wind speed. A small wind turbine might produce around 1.5 to 10 kilowatts of power. To put this into perspective, an average household uses about 10 kilowatt-hours of electricity per day. While small wind turbines might not entirely replace your reliance on the grid, they can significantly reduce your carbon footprint and potentially save you money on your energy bills. Moving up in size, medium-sized wind turbines bridge the gap between small residential turbines and the massive giants seen in large wind farms. These turbines, with rotor diameters ranging from 30 to 100 feet, are often used by businesses, schools and communities to generate clean electricity. A single medium-sized turbine can generate anywhere from 100 kilowatts to several megawatts of power, enough to power hundreds of homes or a small community. These turbines are often grouped together in small wind farms, creating a collective source of renewable energy that can power entire towns or regions. Giants of the grid. Large-scale wind power. The true titans of wind energy are the large-scale wind turbines found in vast wind farms across the globe. These behemoths, with rotor diameters exceeding 100 feet and reaching heights taller than the Statue of Liberty, are capable of generating colossal amounts of power. A single large-scale wind turbine can generate anywhere from 2 to 8 megawatts of electricity, enough to power thousands of homes. These turbines are often arranged in massive wind farms, sprawling across vast landscapes and harnessing the full force of the wind. These wind farms are becoming increasingly common, transforming barren deserts and windswept plains into clean energy powerhouses. Offshore giants, harnessing the ocean winds. While land-based wind turbines have made significant strides in harnessing wind energy, the future of wind power may lie offshore. The open ocean, with its vast expanse and powerful, consistent winds, offers an ideal environment for generating even greater amounts of clean energy. Offshore wind turbines are typically larger than their land-based counterparts, with some models boasting rotor diameters exceeding 850 feet. These giants of the sea can generate up to 14 megawatts of power each, enough to power a small city. As technology advances and costs continue to fall, offshore wind is poised to become a major player in the global energy market. The wind's influence factors affecting power output. While the size of a wind turbine plays a crucial role in its power generation capacity, several other factors also come into play. These factors can significantly influence the efficiency and effectiveness of wind energy production. The most significant of these is wind speed. Wind speed is a critical determinant of how much energy can be harnessed from the wind. Simply put, the faster the wind blows, the more power a turbine can generate. This relationship between wind speed and power output is exponential. Even small increases in wind speed can lead to significant increases in power output. This is why accurate measurement and prediction of wind speeds are so important. Location is another critical factor. The geographical placement of wind turbines can greatly affect their performance. Wind turbines placed in areas with consistent strong winds, such as coastal regions, mountaintops or open plains, will naturally generate more power than those in areas with calmer winds. These locations are ideal for maximizing energy production. Technology also plays a role. The advancements in wind turbine technology are continuously evolving. Advances in blade design, generator efficiency, and other turbine components are constantly pushing the boundaries of wind power generation. These technological improvements help in capturing more energy from the wind and converting it into usable electricity. A future powered by wind. From small residential turbines to colossal offshore giants, wind power is playing an increasingly vital role in the global transition towards a sustainable future. The amount of power a wind turbine can generate varies depending on its size, location, and technological advancements. As we continue to refine our understanding of wind energy and develop innovative new technologies, the potential of wind power to power our planet is virtually limitless. Imagine a future where clean, renewable energy, generated by the very air we breathe, powers our homes, businesses, and transportation systems. This is the promise of wind power, and it's a future within our reach. Want to see more clean energy breakdowns? Hit subscribe and join us in powering the future.